Last couple of videos we've been looking at .NET code analysis, and we looked at the ability to put together a syntax tree within your program, and then also how we can compile that to produce an actual .NET DLL. And what I wanted to do this week was just to give a slightly more practical example of how all of that can be useful. And in fact, this is going to take us back even further to a video I did quite a while ago on dependency inversion and putting together a game for rock, paper, scissors. So if you've seen that one, let's carry straight on from there. But if not, just have a quick look at the link I've put up there, just to remind yourself if you're not familiar. But what we had there at the end of all that was this rock, paper, scissors game. And the way it worked, if I just run it up, is we're asked for player one's name, so we can put in a name. And then we get offered, in this case, just two alternative strategies. We've got a random strategy, which basically means it chooses completely random rock or paper or scissors, and then a non-repeating strategy, which is slightly different. It's random, but it guarantees never to choose the same thing twice in a row. So let's have Harry with a random strategy, and then Sally can have the non-repeating strategy, and then we'll just play 5 games of that. And you should be able to see, it doesn't matter too much, that we've got those slightly different strategies. And it turns out in that case that Harry won. But the thing about this in terms of dependency inversion is that those strategies are loaded dynamically. So if we just take a quick look in here and look in File Explorer and then just drill down, you'll see we've got this strategies folder. And in there, we've got a DLL containing those rock, paper, scissors strategies. And then we've got a strategy factory, which looks inside that folder and pulls out the DLL and basically looks for any class that implements the interface that we have in here, which is IRPS strategy. And what that means is that other developers can develop new strategies and effectively just plug them in, pop them into that folder, and they will automatically be incorporated. So let's do that. Let's just have a custom strategy. So I've set up this project, already got the dependency so I can get in that RPS strategy, and also an enum, which is just where we have basically rock, paper, scissors and the basic rules of the game. So in here, let's do that custom strategy. Let's add a new class, and we'll call this one, keep it something very simple, always paper. And then all I need to do, make it public, implement that IRPS strategy, and get the namespace, implement the interface, and then it's called always paper. So all we're going to do is return sign dot paper. So nothing particularly clever, but the point is, if I build that, then if I run the rock, paper, scissors, we're not yet seeing it because it wasn't actually part of that project. We've got to copy it into the right location. So we go into custom strategy, open that in File Explorer, go down, grab the DLL, and then if we pop that into our other folder, and so now when we run up the main program, and we can see we've now got always paper. Let's just give that to both players. And they're just always getting paper. So it's not a particularly clever strategy. But if that had been a more complex strategy, then in order to develop it in the way I've just shown you, I would require 2 separate sets of skills. I'd require the skills of understanding the gameplay of rock, paper, scissors, but I'd also need to be a C# programmer to put that together. And in complicated domain areas, that is not always going to be the case. I mentioned last week a good place to use this, that I used it, was with actuarial software, where we had experts in writing the formula to predict the value of life insurance policies, but they weren't experts in programming. So we don't really want to have this process that if you want to add a new strategy, you have to program in C#. What I, as a C# developer, should be doing is providing tools for the domain experts, for the rock, paper, scissors experts, so that they can develop these strategy DLLs without having to understand actually how to program C#. And that's what we can do with the code analysis and code compilation. So what I've also got here is this thing called a strategy maker. And if I just set that as the startup project, and then we have a look at what we've got in there so far. It's really very much like what we saw with the code compilation. So we've got this string builder where I'm putting together, to start with, just a very basic strategy, in this case rocks only rather than the always paper that we had in that previous example. And you can see it's just text there put together, and then we return this rock. Now, I've done that as text. We saw the other week that the alternative way of doing this is to actually build up your syntax tree using this syntax factory. And it was all quite complicated. That code there was just to put together a Hello World program. And although in more complicated cases this may be the way to go, I think just for now it's easier just to be putting this together as text. So we have that text, and then we've got that converted from the text into the tree, and then we've got this build assembly, which again is pretty much the same as I showed you last time. Remember, what we have to do is include the various other assemblies we're referencing. So that's slightly different from last time because it's a different program. But notice the really important one. There we've got that rock, paper, scissors .basics, which is where we're getting hold of the interface and the enum and the other related things. So that's definitely got to be in there. And then the only other difference from last time, we're outputting this as a DLL, not as a console application. There, with a bit of a convoluted path, that's that strategies folder, which is where we're keeping them all. And so it will just do the same sort of compilation as last time. So at the moment, there's no ability for a user to choose how this works, but let's just give that a run so we can see it's working. So all that's going to do, if I run that up, is it doesn't tell us anything. But if we look at the folder for strategies, we'll now see we've also got that rocks only DLL. And so if we switch back to the main program and run it, we can now see we're getting a rocks only. And if I select that, so let's do rocks only versus always paper, then we can see it's just working. So the strategies themselves aren't at all clever, but the point is they're added dynamically. But what I want to do, though, as I said, is develop a tool to allow rock, paper, scissors experts to produce these things without having to write any C# code for themselves. And although it could be hugely flexible, the kinds of algorithms that are played, I'm going to limit it, just to keep this brief, so that we can select the proportion of probability for getting rock, paper and scissors. So we can say we want 10% scissors, 20% rock, 70% paper, or whatever it may be. And so they can just run the program, configure that, generate the DLL without writing any C#. So let's do that. So what I'll do here is let's firstly output a message. So we'll do a console write, and here we'll ask them for the percentage rock. And then we'll say int PC rock equals, and then we're going to have to do an int dot parse, and then a console dot readline. And then if we just copy that, we'll have a percentage paper, and we'll call that PC paper. And then obviously the percentages have to add up to 100, so we can just say int PC scissors equals 100 minus PC rock minus PC paper. And then let's just confirm that. So we'll do a write line, and then we'll have PC rock percent rock, PC paper percent paper, PC scissors percent scissors. So that'll just give us a message so we can see and confirm that we've done it correctly. So that's entered the information. Now we need to start modifying this program, or the text that is going to become this program, so that it is going to do that correctly. And so it's basically this bit that's going to have to change. So inside that throw. And what we're going to do, something that we actually have available to us already, you'll notice if we look at the other strategies, like our random strategy, is we've actually predefined on there this random, which is just a static property of the interface that gives us a random number generator. So we can use that because remember, we've included this assembly into our build. So if we go back in here, what I can do is I'm going to say int val equals, and then we say underscore random dot next, and then because we're using percentages, it's going to be a value in the range 0 to 99. And the thing you immediately notice here, which isn't much fun, is that obviously I'm not getting any IntelliSense or anything like that because it's all in text. What I'd probably be doing if this were a real project, I'd actually be writing this out while I develop it using a normal C# editor to get all that help, and then I'd turn it into text later on. But for now, we'll go straight in there. So we've got that random value. So next thing we need to do is we're going to say if val is less than, and then I'm going to insert into there the value that we've just read in. So if val is less than PCROC, so that's going to insert into the text the value I've got of PCROC. So if that's where we are, then we're going to need to return rock. So we'll put in the indentation purely for our benefit. The compiler doesn't care. We'll say return and then sign.rock. So use the enum. Then we'll have an else if val is less than PCROC plus PC paper. And so we'll return paper. And then finally, we'll just have an else. It can't be anything else now. And we'll have sign.scissors. So the actual program is pretty static, but we're inserting into it those values of rock and paper. Actually, the value of scissors doesn't really matter because, again, we're just assuming it all adds up to 100. Then one other thing we've got to do is actually, this is no longer called rocks only, so we're going to change that. And in fact, let's ask another question. So we'll have, what do you want to call your strategy? And then we'll have a string name equals console readline. And so that's what we can put in there. So we'll put the name in there. So that should produce for us a program. Pretty simple, but it's something that's being configured now once we run this, not by writing code, but just by filling in those numbers when we're asked. One other thing we need to do down here, we need to change that to name.dll, so whatever the name is they've entered, that's what they'll get. And so that should all be working okay now. So we ask the questions, the expert in rock, paper, scissors can decide exactly what percentages are best to play the game, but then that will generate a DLL, and then the DLL, remember, will get saved into the strategies folder, and then next time we run the game, will be immediately picked up. So let's just set our startup project back to Strategy Maker, and then run that, and it will ask us percentage rock. So let's go for 10% rock, 20% paper. So it's shown as that. We'll call this strategy, well, let's make it clear. We'll call it 10, 20, 70. And then when we hit return on that, we got an error. Because that has to be scoped to the name of the interface. So I could call that a deliberate mistake, but it's quite nice that one cropped up because it just shows us that we do get the compilation errors. So that actually needs to be irps strategy dot underscore random. Run it again, same sort of thing, 10, 20, and then we call this 10, 20, 70. And then we get no errors, and I won't even check in the folder. I will just switch back to the actual game, run that up, and we can see we've got 10, 20, 70 listed in there. So that's the one that we'll get Harry to play. And then let's have Sally, and let's just put rocks only on there so we can see what's going on. And then, so that we can just look at the stats, let's make quite a few throws, so 20 throws. But if we look at what Harry has played there, and if we go through the numbers, you should see certainly quite a preponderance of scissors from Harry, because that was 70% of what was being played, and you can see quite a lot of those there. So really that was it, just putting things together to show not a hugely practical example, but something that you can see if you expanded this into something more complicated would really reap the benefits. So we've got this issue that we have domain experts, we have software developers. I'm a software developer. My job is to produce tools that the domain expert can use easily, and we've got one there. They just have to enter the percentages and the code is generated for them and immediately be able to use. So I hope that was helpful. Any comments, do put them in the section below. Do click the like button, do subscribe, and I'll see you next time.